Well, it seems the solar powered butterfly is happy because we've got some sun, and I've been working on the solar power DMM, the solar panel test rig, and I've hooked it up to my 20-watt panel here, and let's have a little look at what's new. So we now have the current sensor, which is there, the ACS 712 Hall effect current sensor. The voltage sensor is here between the yellow and black connectors, and the Arduino has a new green display because the blue one didn't show up terribly well outdoors. So I've now managed to put the necessary maths in for volts and amps from the current sensor, and of course then multiply those together and you get watts. Now the amps is a little bit jittery at the 0 level, but you can see that whenever it goes to 0, whenever it zeroes out properly, the watts is also 0. Now the voltage there is the open circuit panel voltage. So with a 20-watt panel coming in, and you can see there on red and black the circuit is open, so there's no current. We've got voltage, but of course that means there are no watts. So let's actually close the circuit and see what happens. So I've now put this shorting link on red and black, so the circuit is closed. Solar panel comes in on yellow and black, and there's a dead short. And the readings are no volts, of course, because we've shorted them all out. But we're getting current there, look, 1.2 amps flowing around that circuit. But because there are no volts, of course we've got no watts. And that's interesting because in both cases, open circuit voltage and short circuit current, you get no power. So how do we get power? Well, we have to put the solar panel into a range where it can develop both volts and amps. So what I'm going to do is take the shorting link off and put a light bulb on there just for a moment. So this is the familiar 20-watt, 21-watt car brake light bulb. There's a dim glow on it, and I've connected it in to the circuit. So now we've got solar panel through the DMM and into a light bulb. So we've got both volts and amps. Let's have a look. 6 volts. Now if you watch my other video about the mismatch between a 20-watt bulb and a 20-watt panel, you'll know that they are very badly mismatched. So we're not getting maximum power voltage from the panel, we're getting just 6 volts. We're getting the 1.2 amps that we were getting before, because pulling a solar panel's volts down doesn't affect the amps particularly. And so the watts we're getting is around, well, that's 7 watts, isn't it? So no wonder the bulb is dim, it's a 20-watt bulb. We're only putting 7 watts through it. So that's the latest situation of the solar DMM. What I want to do next, of course, is put on this right-hand side a DC to DC converter and see if we can do some matching. The ultimate aim, of course, being to turn this into a maximum power point tracking solar charge controller for charging car batteries.